Hello again, everybody, and welcome to part 2 in our loan series here. Today we're just going to look at a few more examples, and hopefully that'll help you out. So we're going to get right into things. Example 3. Annette wants a loan. Her bank will charge her 3.6% compounded quarterly. She already has a 10-year GIC that will mature in 5 years. When her GIC reaches maturity, Annette wants to use the money to repay the home improvement loan with one payment. She wants the amount of the payment to be no more than $20,000. How much can she borrow? All right, so let's get into this question. Part A. So the first part we should likely think about is if there's simple interest or compound interest. And once again, I see the word compound here, so I know it's compound interest. And we want to know now if it's compound interest, is it one payment or is there multiple payments? And it says she wants the amount of the payment to be no more than $20,000, so she's making just one payment. Remember, we always want to assume that everything's one payment until we see language that tells us otherwise. Also, I want to remind you that I got a bit of a cold as I'm recording this, so I might have to stop and start a little bit when I'm coughing, so sorry if the sound is a bit funny. Anyway, so we know we're using the formula. Now in this one, she knows in the end that she wants the payment to be no more than $20,000. So the future value is going to be $20,000. That's what she wants it to be in the end. What we're going to be wondering is, well, then how much, for that to happen, how much should she borrow now in order to make sure it's only $20,000 in the future? So we're going to be looking for the p-value. Now I'm going to be finding the rest of this. So interest, now remember, interest in the formula we have to put in as a decimal. N is a compounding frequency, and it's quarterly, it says in the question here. Quarterly. And the time frame, it says 5 years, matures in 5 years. Okay, so normal compound interest formula, but we're going to be looking for this p-value. So what I suggest to you is I usually just consider the basic compound interest formula, and then I know that I'm looking for p. So then I just rearrange the formula. So I'm going to divide both sides by this bracket here. Now, it just gives you a little bit more of a direct route to your answer. And I like just manipulating my equation like this so that I don't have to worry about memorizing another formula. So I just think about the first formula and then know I can rearrange it if I need to. So here is a version of the formula that I'm going to use. So if you just want to memorize it, you definitely can, but I prefer just to be able to rearrange for it. Anyway, let's get back to this. So I'm going to move this up a little bit higher to make sure I have room. P equals an A, which is 20,000, divided by 1 plus 0.036, divided by 4. To the power of 4 times 5, which we know is 20. If you want to write 20, go for it. All right, then you got to get your calculator out and start plugging things in, and you get $16,718.86. All right, so that is how much she can borrow now if she doesn't want to have to pay back more than $20,000 in the 5 years. So that's A. B, how much interest? Okay. We talked about this in the previous video. Remember, interest, the way I like thinking about it, I think for this stuff, is how much you had to pay back, or paid, I was writing before, but pay back, if that makes more sense to some, minus how much you originally borrowed. So she needs to pay back the $20,000. And she borrowed just this answer we found, the $16,718.86. And then once again, get your calculator out, do that subtraction. $3,281.14. So that's how much interest she'd pay. Example 4. Jose is negotiating with his bank for a mortgage on a house. He has been told that he needs to make a 10% down payment on the purchase price of $225,000. Then the bank will offer a mortgage loan for the balance at 3.75% compounded monthly, with a term of 20 years and with monthly mortgage payments. A, how much will each payment be? All right, the first thing we should talk about is how this purchase is going to go. So the house is being sold for $225,000. Well, Jose has to come up with 10% himself, and then the bank is going to give him a mortgage for the remaining 90%. So we need to figure out what the 10%. So I guess before I even get into that, this will be bank. And this will be, I guess, his savings or whatever, but we usually call this just a down payment. I'm just going to write down pay. All right. So to figure that out, we just have to multiply those things by the 10%. So 10%, I want to get a different color, I'm sorry here. 10% in this, for the 10% of the 225,000, I'm having trouble talking, can you tell? It'd be 22,500. He needs to have that much himself. Then the rest, the bank will cover. Now the rest would be $202,000, 500. So you can see the bank's covering a big chunk, but he has to come up with some too. So any type of purchase question or house purchase, you're going to have something like this happen in the textbook. Okay, so we've got that hopefully explained that you have to come up with a down payment and then the mortgage goes through the bank. Before we start, I guess, simple or compound interest. Well, you know what, I can kind of stop that because this question says right here, right away, monthly mortgage payments, right? But it also asks you how much will each payment be. So that should be a clue that we're dealing with regular payments. But if not, is it simple or compound? You'll see the word compound right there. And then we'd get into, okay, is it a single repayment or multiple repayments? And then you can see it's monthly mortgage payments. So, time to write out my calculator settings. Okay, so again, he's already paid $22,000 himself because he had to come up with a down payment. So it says the bank will offer a mortgage loan for the balance. That means the rest of it. The interest is 3.75. The value of this loan is the $202,500. Okay, not the $225,000. We only want 90% of it. Now it says how much will each payment be, so that should be what we're looking for. The future value will be 0. We're assuming we're paying it off. It's monthly mortgage payments, so it should be 12. And if I check out the wording, it says compounded monthly. Great. Now, if we're going to find the payment, that means I must know the end value, which is the total amount of payments. Remember, that's the payments per year multiplied by the time. Payments per year is 12. The time frame, it says 20 years. So 240. Okay, I have all the details I need. I punch that stuff into my calculator. I get $1,197.55. Okay, and it says how much will each payment be? It's that amount, so we've figured out that question. So that's part A. In part B, it says how much interest will Jose end up paying by the time he's paid off the loan in 20 years? Okay, so the interest, it's the same idea. It's going to be, you know, what you've paid versus what you borrowed. But we have to, it takes a little bit more figuring when we're dealing with payments again. So what you paid minus borrowed. But remember, he made payments. So for the paid, remember he made $1,197.55 payments, and he made 240 of them. So to figure out how much he paid, you have to actually do that. You got to go the payment value times the amount, so the N, and then we'll subtract what he actually borrowed. Remember, he didn't borrow the full amount. He borrowed $202,500 because he had to pay for the other 22. Okay, and then we just have to work that out. So that works out to the interest being $84,912. And that is part B. Part C, how much will he pay altogether? So that means in the end, how much did this house truly cost him? So the cost of the house would be his down payment. Plus the mortgage. Wow, can't spell for a second there. Now remember the down payment he ended up paying $22,500. That was out of his own savings or whatever. And then in the mortgage, what did he end up paying again in the mortgage? Well, I guess he made his payments. He made that value of payment 240 times. So we're going to put these values together, and then you end up getting $309,912. $309,912. Okay? And that's how much he paid altogether for his house, even though the list price was $225. Once all the interest kicked in, he paid a lot more than that. Okay, our final example, example 5. It says, Bill has been offered the following 2 loan options for borrowing $8,000. What advice would you give? Well, before we can give any advice, once again, we actually have to see what these things cost. And once we know the value or the cost of these things, then we can actually give some advice. So let's actually check out what each option would cost Bill in his scenario, and then we can advise. So option A. Oops, my pen. Option A. So it says he can borrow at 4.06 interest compounded annually and pay off the loan in payments of $1,800.05 at the end of each year. So right here, you guys, it says payments, meaning more than one payment. So that means it's going to be regular payments. So that's kind of nice for us because that's a little bit quicker. Oh, geez, I'm having some troubles with my pen here. Sorry, guys. Sneak this in. All right. So 4.06 interest. Compounded annually, so it's compounding once per year. He's paying it off in payments of $1,800.05. And at the end of each year, so how many payments per year? He's making 1 payment per year. Okay, now remember he's borrowing $8,000, so negative $8,000. We think he's going to pay the loan off. That's what our plan is. So then we will solve for n. $4.99, but it kind of keeps going here, so I guess I'll round that one actually to 5. Now we want to know the actual cost of this thing. Let me get rid of that little mark on our screen here, guys, real quick here. Okay, back to it. The cost, okay, that's going to be, again, your payment times the amount of payments you make. He made an $1,800 payment, and 5 cents, I guess, and he's actually makes 5 of those payments. So what does that work out to be? That works out to be $1,000.25. Sorry, I had a cough there, guys. I had to cut off the video. Hope that sounded okay. Option B. Option B says he can borrow at the same interest rate, compounded weekly, and pay off the loan in payments again. So we're going to have the same idea. Same idea. I'm just going to write this stuff out. Okay, interest 4.06. Present value, that is the negative $8,000. That's what he's paying off. He's making $34 payments, $34.62. Future value is 0. He is it's compounding weekly, and it also says pay off the loan in the $34 at the end of each week, meaning it's weekly payments. So again, we'll have to solve for n. When you solve for n, you'll get 254.93. Okay, and then we want to see the cost of this plan. So again, the value of your payment, $34.62, and that's going to be multiplied by the 254.93, meaning he's making 254 full payments and then 1 partial payment. once we get that together, so $8,825.68. Okay, so what would your advice be? Well, your advice likely would be to go with option B because he pays less interest in that model. So that's your advice, Bill. Go with option B. Okay, that wraps up everything for this second part of the loans video. So you've seen now 5 different examples using loans. Hopefully that makes some more sense. If it doesn't, make sure you come find me. Have a great night, everybody.